So today on the bench I got this tuner. This is the AM antenna. Nice. It's a Philips FT145 digital synthesized tuner. It's from the 1980s, I think. Well, all the buttons are there, even a narrow wide filter. Where do you see that these days? So apparently one of the output channels is not giving any audio. Let's check that out and hook it up to the oscilloscope. Well, indeed, there's only the right channel giving sound. Well, it looks like the left channel is giving some signal as well. Let's zoom in a bit and see what we've got. Well, there is output on the left channel, but I had to decrease the scale. And it's at 50 millivolts compared to 1 volt, so the signal is approximately 20 times weaker than in the right channel. So that's a problem. So let's open it up and see what's going on inside. I've downloaded the service manual, that's always a good starting point. So let's start with the basics and check if the power supply is okay. This is the transformer with the center tap, and these are the rectifier diodes, 2 large caps to minimize the ripple on the DC. And here we've got transistors acting as voltage regulators. So this one gives 11 volt, 5.6 volts, 20 volts, negative 9 volt and negative 30 volts. So let's check on the circuit board if these voltages are present. This is the first one and it should have 11 volts at the emitter, 11.8, so that's okay. This is the 7373 and it should have 5.6 at the emitter. 6.2, well, okay. The 7372 should have 20 volts. Well, it's this one. It's hard to reach. $19.6, so that's okay. The 7374 should have negative 30. These transistors are all over the board. Negative 29, so that's okay. So the 7371 should have negative 9 volts. And it has 9.5, so that's perfect. I think the power supply is okay. Perhaps not everyone is familiar with what's going on inside a radio receiver. So let's talk about some of the highlights real quick, so we know what to look for in this specific one. So the antenna of a FM receiver is especially made to pick up all the signals of radio stations in the FM band. The FM band ranges from 88 MHz to 108 MHz. In that range there are a lot of radio stations, like at 102 MHz or 98 MHz or 93 MHz. So to listen to a specific station, the tuner has a filter that filters out exactly one station of the FM band. To tune into a station, the FM band is shifted up or down so that the station you are looking for is exactly at that frequency the filter is made for. So there's a tuner IC to shift the entire FM band up or down. So at the end of the filter, we've got the signal of the specific radio station. This signal is fed to a FM decoder to get the sound out of the FM signal. The signal coming out of this decoder is a so-called composite signal. It consists, in fact, of three signals. One is the mono signal, the left and the right channel together. There is the stereo information, so the mono signal can be split up into a left and a right channel, and you end up with a stereo sound. And there's a pilot tone to inform the receiver it is in fact a stereo signal. If it's a mono station, the pilot tone is omitted. So this composite signal is fed to a stereo decoder, which in fact turns this composite signal into a left and a right channel. So let's take a look and see if we can recognize these different parts inside the tuner. So this is the high frequency part where the antenna is connected to the tuner. And this is the tuner IC that shifts the entire band up or down to get the right station at this filter over here. And the output of the filter is fed to this FM demodulator. And the output of this demodulator is going to this stereo decoder to split it into a left and right channel, which is fed to these output wires going to the amplifier. I haven't got the equipment to test the high frequency signals, but I can check the output of the FM demodulator. That's the composite signal and it holds the mono output. So let's check this diagram, and the output is at pin 8 of this FM demodulator. So let's take a listen and check if we have some audio at pin number 8. Yeah. So it seems like this tuner is receiving radio signals correctly up to this point. Let's check the next step, and that's the stereo decoder. So the left channel is at 15.
Dat je niet zomaar...
Yeah, and the right channel is at 16.
Want ja, we leven...
So both channels are present, so that's okay. Let's see what's going on further downstream of this stereo decoder. So this is the left channel going to the output connector. And this is the right channel. Both channels go through this decoupling capacitor and resistor before the bandpass filter. So let's check at those points if the audio is still okay. Well, these are the decoupling capacitors and resistors. So let's check if we have audio.
Allemaal wegneemt.
Yeah.
Denk ik dat...
This one is okay. No. We've got nothing. Oh, there's a very faint, it's a very weak signal. Let's check the capacitors. This one is okay. And this one has nothing.
Bij te gaan. Of niet. Of je zegt, oh, ik ben benieuwd.
This one has no output. Well, it's very faint, like we saw on the oscilloscope.
Leuk. Nou, gaan we proberen.
So I think we got a problem. So we need to replace this capacitor. In fact, let's replace both, so we keep the same characteristics for the two channels. Okay, that's one. And that's two. Let's check these on the component tester and see what's going on. That's 1 microfarad, as it should be. Let's check the other one. Wow, 1200 picofarads. That's 1.2 nanofarads, so that's way too low. Let's get some new ones. All right. All right, just checking if everything is okay. Looking good. Also looking good. Let's put the tuner back together again. All right, let's hook it up to the oscilloscope and see if the repair was a success. Let's turn it on. Yeah. Both channels look more or less identical, so I guess this is a fix. I hope you enjoyed it. Thanks for watching, and I'll see you guys in the next video.